Okay, so let's look at the first one here. So we're looking for how many moles are in 65 grams of water. Okay, so pretty straightforward one. Just looking for N, right? So N is our question mark. Okay, they told us the mass. It's 65 grams. We know the molar mass of water because we can calculate it from the periodic table. 1.01 times 2 for our 2 hydrogens plus 16 for our single oxygen is 18.02 grams per mole. All right, so you get 1 mark for that. Okay, next thing we got to do is just plug into the formula because it requires no manipulation. Mass divided by molar mass. 65 grams divided by 18.02 grams per mole. Okay, so 65 divided by 18.02. All right, so we got 3.61, okay, because that's our final answer. So we're rounding off now. 3.61 moles. Okay, questions on the first one? All right. For question number 2, we're looking for the mass of 8 moles of magnesium chloride. Okay, every time I have a unit exam, I put on a question just like this one, where you have to drop and swap correctly to get the correct answer. So it's really important that we remember, if we're given an ionic compound, okay, that we have to drop and swap it. We cannot go like this. Okay, if I go like this, I'm not going to get the right molar mass, and everything I do with molar mass after that is going to be wrong. Okay, so this is a 2 plus, this is a 1 minus, so we're looking at MgCl2, okay, which is going to be 24.31, yeah, 24.31 for magnesium plus 35.45 for our chlorine, and there are 2 of them. Okay, so we got 24.31 plus 35.45 times 2. So we got 95.21 grams per mole. Okay, and the other thing we were told was the number of moles, 8. So now I need to manipulate the mole equation to solve for little m. So I'm going to multiply both sides by big M. Big M comes over here. Okay, so we'll have little m equals 95.21 grams per mole, the molar mass, times the number of moles, 8. Right, gives us 761.68 grams. Okay, so 1 mark for your answer, 1 mark for that, 1 mark for the manipulation, 1 mark for the givens, 4 marks. Questions on number 2? Okay, how many people have done number 3? All right, let's go over number 3 as well then. Okay, so how many molecules of sodium sulfide are in 200 grams? Okay, so they gave us what here? Right, they gave us little m and big M. So little m is 200 grams, and big M is sodium sulfide. That is Na with S, which is a -2. Sodium is a +1, so we're looking at Na2S. All right, so that's going to be 22.99 times 2 plus 32.07. Okay, so 78.05 grams per mole is our molar mass. Okay, what can I find with little m and big M? N, the number of moles. So that's the next thing I want to do. Okay, N equals little m over big M, so that'll be 200 grams divided by 78.05 grams per mole. Okay, so here's where we want to keep all the decimals. I'm only going to write 2.56 moles here, okay? But I'm going to keep all of the other decimals in my calculator. Okay, so I've got 2.56 moles, and what number do I need to go with that in order to get the number of molecules? Right, I need Avogadro's number. Am I multiplying or dividing? multiplying because I have more than Avogadro's number here. I have, okay, 2.56, so I'm going to multiply there. All right, so the number of molecules, sorry, will equal n times Av's number, okay, which will be 2.56 with all the other decimals, okay, multiplied by 6.02 times 10 to the 23. Okay, so I'm just going to take that and go times, then it keeps all the decimals, right? 6.02 E23. All right, so I get 1.54 times 10 to the 24 molecules. Okay, so that's a 4-mark question, 1 for the answer, 1 for this operation, 1 for that operation, and 1 for the givens. All right, how many people are done number 4? Okay, I'm going to give you a few more minutes on number 4. If you're done number 4, finish up the worksheet from yesterday there. Okay, so we're looking for the mass of 1.2 times 10 to the 25 molecules of iron 2 nitrate. All right, so they gave us the number of molecules, which I can always use to get the number of what? Moles, as long as I divide by Avogadro's number. Okay, so we've got here that we got to calculate n first. So we're going to take our 1.2 times 10 to the 25, the number of molecules we have. Okay, so this is molecules. And then we're going to divide by Avogadro's number, which is essentially molecules per mole. I mean, really, that's what we're saying. It's the number of molecules in 1 mole, so it's really molecules per mole. Okay, so molecules cancels off, then I'm left with moles. Okay. All right, so we're going to have our 1.2 to the 25 divided by Avogadro's number, which says, whoa, oh, I multiplied. Better. Okay, so we got 19.93. I'm only going to write 93, but what am I doing with all the decimals? Okay, 19.93. All right, so I've got that. Now, next thing I got to do, calculate the molar mass of iron 2 nitrate. So this is iron with the 2+ charge. Nitrate is a -1. So brackets around the nitrate with a 2. So we got 55.85. The one iron that we have 2 nitrogens, so 14.01 times 2. And we have how many oxygens? 6 times 16. All right. All right, so 179.87 grams per mole. Okay, so that's what we got for there. Now, what's my next step? I haven't used what equation yet? I haven't used the mole equation yet. All right, so N equals little m over big M. I'm looking for little m, so multiply both sides by big M. Okay, little m is going to equal our 19.93, the number of moles with all the decimals, okay, multiplied by 179.87, the mass of 1 mole. Okay, so 19.93355482. Okay, so I'm going to have 3,585.44. What are my units? Grams. Five marks for that one. Okay. Questions there? All right.